Hello everyone, welcome back to my YouTube channel. I am Vaishnavi from Sri Venkateshwara College of Engineering, Department of CSE AI. Today in this video, I will be discussing about basic concepts of probability. In that, majorly I will be discussing introduction, sample space, event, union and intersection, addition rule, multiplication rule, Bayes theorem, and other basic concepts. Let us start with Introduction to Probability. Probability is a branch of mathematics that deals with the livelihood of events occurring. It is used to quantify uncertainty and make predictions in various fields. Probability is expressed as a number between 0 and 1, with 0 meaning impossible and 1 meaning is certain. Sample space. The sample space is a set of all possible outcomes of an experiment. It is denoted by a symbol of sample space and letter S. For example, when tossing a coin, the sample space is heads and tails. And if a single die is rolling, the sample space is S equals 1 to 6. Event. An event is a subset of sample space. It represents a specific outcomes or a combination of outcomes. Events are denoted by capital letters such as A, B or C. Probability of an event. The probability of an event A, denoted as P of A, is the livelihood of an event occurring. It is calculated by dividing a number of favorable outcomes by a total number of possible outcomes. The probability of an event ranges from 0 to 1. Union of events. The union of two events A and B, denoted as A union B, is the event that at least one of them occurs. It includes all outcomes that are in A, B or both. A union B equals P of A plus P of B minus P of A intersection B. The probability of an union of two events can be calculated using the inclusion or exclusion principle. Intersection of events. The intersection of two events A and B, denoted as A intersection B, is the event that both A and B occurs. It includes only the outcomes that are common to both events. P of A intersection B is less than or equal to minimum of P of A, P of B. Independent events. Two events A and B are independent if the occurrence of one does not affect the probability of the other. P of A intersection B equals P of A or P of B. Mutual exclusive events. Two events A and B are mutually exclusive if they cannot occur at the same time. If P of A intersection B equals 0 or P of A union B equals P of A plus P of B. Conditional probability. Conditional probability is a probability of an event A given that another event B has occurred. Denoted it is as P of A and B. P of A and B equals P of A and B divided by P of A. Addition rule. The addition rule states that the probability of a union of two events A and B is the sum of their probabilities minus the probabilities of their intersection. P of A union B equals P of A plus P of B equals minus P of A intersection B. Multiplication rule. The multiplication rule states that the probability of an intersection of two events A and B is the product of their probabilities. Bayes theorem. Bayes theorem is used to calculate the probability of an event a given probability of another event B, and the conditional probabilities of A and B. P of A and B equals P of B and A into P of A divided by P of B. Expected value. The expected value, also known as a mean or average, is the long-term average outcome of a random experiment. It is calculated by multiplying each possible outcomes by its probability and summing them up. Variance. Variance measures the spread and dispersion of random variables. It is calculated by subtracting the expected value from each possible outcomes squared, multiplied by probabilities and summing up them. Standard deviation. It is a statistics that measures how depressed the data is in a relation to the mean. Standard deviation is a square root of variance and provides a measure of depression of a random variables. Probability distribution. A probability distribution describes the likelihood of different outcomes in a random experiment. It assigns probabilities to each possible outcomes. Examples include in binomial, normal, and Poisson distributions. Random variables. A random variable is a variable that takes different values based on the outcome of a random experiment. It can be discrete or continuous. Random variables are denoted by capital letters such as X, Y, or Z. Probability density function. The probability density function is used to describe the probability distribution of an continuous random variables. It represents the likelihood of different values occurring within a given interval. The total area under a probability density function curve is equal to 1. Let us conclude the session. Basic concepts of probability. Probability is a fundamental concept in mathematics and statistics. It allows us to quantify uncertainty and make predictions. Understanding the basics of probability is essential in various fields like including the finance, healthcare, and even in a science. Thank you for watching my video.